All right, so this is how we study, or that was how we study climate change over long periods of time. Now, what have we found, right? What do we know? Well, we know that global climate changes all the time, naturally changes. Global climate history naturally oscillates between warmer and colder climate periods. Those warmer periods we call greenhouse periods, and those colder periods we call icehouse periods. So greenhouse Earth is very hot, icehouse Earth is very, very cold. The image I'm showing here is going back over 3 billion years, all the way to the beginning of Earth, and showing with that red line when the Earth was relatively cold and when the Earth was relatively warm. And you can see that there's a lot of wiggles in that line, right? Sometimes Earth is very cold, sometimes Earth is very warm, but it wiggles back and forth. Over the last about 100 million years, Earth has experienced a warm climate. However, it has, over the geologic scale, been cooling recently. Okay. So why do we experience these oscillations in climate? Right? Well, there's lots of different reasons. We're going to quickly go through several of those. One of them is how ocean water circulates around the Earth. We've previously talked about how ocean water can change the climate of land, right? How if there's cold ocean water, that can lower the surface temperature of the land, causing less evaporation and a desert to form on land, right? So where the water goes, it takes its temperature with it, and it can actually change the temperature of the land. An example of when ocean currents have changed global temperature is when the Isthmus of Panama closed during the Miocene. So the Isthmus of Panama, that is the current strip of land that connects North America to South America. Before the Miocene, that strip of land did not connect the two continents. So water, really warm water near the equator, was able to circulate around the globe, right? So bringing warm water, warm conditions all the way around Earth. However, when the Isthmus of Panama was formed, that strip of land cut off circulation around the equator. So that warm water was no longer able to circulate around the globe, and that caused global cooling. So because tectonics caused that tiny little strip of land to form, the entire climate of Earth cooled. We've also talked about how rocks can trap carbon within them, taking carbon out of the atmosphere and cooling the global climate. And we also know that Carboniferous rocks, right, rocks with a lot of carbon, are sometimes, formed more during some periods than in other periods. We talked about how the Carboniferous period was actually called the Carboniferous because it contained so much coal, which contained so much carbon. So during the Carboniferous, because all of that carbon was getting stuck and trapped in coal-forming rocks, the global climate actually cooled. Right, life has also changed climate, and not just humans. All life has changed climate. So the appearance of the first lichens, those are those really vibrantly colored organisms that can grow on rocks. When they first came about, they took down carbon dioxide out of the atmosphere, actually causing the Earth to go into icehouse conditions, causing the global temperature to cool very quickly. The appearance of the very first grasses, when grasses evolved in the Miocene, had very similar climate impacts. So as this life evolved, this vegetation evolved, the climate cooled. Very opposite to what we're doing today.